Good morning, good evening, good afternoon, wherever you are, whatever time it is. Thank you for joining us for a mechanical overview of Crash. This, as some of you do know and some of you do not know, is Crash. He's a robot that I started building back in November of last year. He's a simple project. He started with a simple idea. I wanted to make something that was somewhat of a pet to run around the house. Something that was anthropomorphic that I could relate to when I interact with it, and that my daughter and my wife could relate and interact with easily, that was comfortable and easygoing. So he started as an idea, just something I scribbled out on some paper, and I took inspiration from a lot of different machines. Johnny Five, Robbie the Robot from Lost in Space, and there's an old movie called BB about a robot that murders people. And I took some inspiration from his design as well. I'm an 80s kid, so I definitely like the 80s era technology when it comes to circuits and building things of that nature. So I've decided to do some things on him a little differently than other people might do in order to kind of capture that flavor of robotics from that era that I wanted, like with his text-to-speech board that we built. So without further ado, let's dive on in. The tracked base is where we started. And that was just a simple thing that I ordered from Amazon. It's got dual decks. I used the lower deck with prototyping boards so that I can test out new circuits and new ways of hooking things up, and then from there it gets installed. This is the primary CPU. It's a ESP32, plenty of space. Currently, his operating system is a multi-chipped operating system. I'll go over more of that in a minute. But it's written in C, more or less C. It's the Arduino IDE, but I use another editor a lot called Notepad+. And it's nice because I can write everything in that and then just copy it over into a sketch window when I want to upload it, and it works pretty well. His second board, which is kind of hard to see back here, this is an Atmega. It's what the Arduino was originally built on and based on. I think it might be the same chip now, but it's a serial servo controller, and it's 32 channels, so it'll do up to 32 servos. And it's serial, so you can send a command to it, just a string of data. You tell it which servo number you want to address, you tell it the position you want the servo to have, and you tell it how long it has to get to that position. And it does it, so it's really easy to interact with a lot of servos if you want to make like a walking machine or something like that. So it was perfect to use for his arms. It also controls servos for his neck, his waist, and this servo, which had a burned out motor. I ended up using this just as a position device to run this linear actuator in the back to raise him up and down. He is capable of self-balancing. If you tip him forward, he'll lean backwards, and if you tip him backwards, he'll lean forward. This servo here is currently unpowered, and I'll go over more of that later on as well. That would be this one here. That's his upper waist. Inside the tracked base, we have his motor controller. There we go. Which is tucked away back in here. That's a model that a lot of people don't like. It's the LM298 something or other, I believe. But it's worked all right for me. Eventually, we're probably going to upgrade to something else, but they're cheap. That's what I had on hand. The motors are DC motors. They run on up to 12 volts. The entire system is powered by 4 of these. He's got 2 battery bays. Each bay holds 2 of these 7.2 volt, 3600 milliamp hour batteries. So all 4 of those give him a total of around 14 and a half amp hours of power. You can see 2 of them strapped in right here. The other 2 go over here. This is an infrared adapter. I don't know where the cord went to that. It was hooked up. My cats like to climb on this a lot and bite on it when it's not being used. But this detects the ground underneath him. That's kind of mashed up too. Holy crap. and this is used to determine when he's picked up and when he's moved around. I have rotary encoders that go on these, but I had to remove them. One of the problems I had early on with his design was EMF and back EMF from the drive system contaminating the I2C bus. And I tried filters, I tried resistors, I tried capacitors, I tried RF chokes, I tried, oh god, all kinds of things to try and get rid of that noise. And what would happen is one of the okay, sidetracking, I do that a lot, please bear with me. One of the features that I really wanted on him was this big blue display on his chest. When I first started drawing him out, I knew that I wanted certain things, like I wanted him to look kind of a certain way. I didn't have any set designs, like I was going to build this machine and it was going to be just like this and it was going to do all of that and it was going to be awesome. And I kind of left a lot of it in limbo and figured it out as I built it. But one of the things I originally wanted was this blue display, and this display has gone through many modifications in order to keep it on the project. So the I2C bus, whenever he would drive around, it would work, but after a couple of minutes, all of a sudden, all the data on the screen would get garbled. And his eyes would get garbled, and anything I had on the I2C bus would just stop working. So I hit a bunch of things with my oscilloscope and my multimeter and kind of figured that it was interference, but I could never nail it down. However, it only happened when the drive system was working, so I knew it was the drive system. And the fix I ended up doing for that is this string of optocouplers right here. We've got the 4 that control the forward and reverse of each motor, and then we've got a 5th that controls the PWM, or the speed of the motors together. Instead of having each controlled their speed independently, it sends out one speed and then drives them forward or backwards at that given speed only. And that's how his drive system works. But this is what it took. That's our light sensor too, by the way. Just really simple. It's got a resistor and it plugs into one of the pins. And this is all bundled and it goes to the back to the motor and controller. So the motor controller uses its own set of batteries, and then crash and everything else runs on the other set of batteries. I have a crossover switch. If I need to, I can click it and draw from all the batteries at once, which I often do if I'm not using the drive system, which I don't do very often because he spends a lot of time on the desk being worked on. On this side, I've used for prototyping all kinds of stuff. Right now it's set up for playing with the I2C bus. I had chips on this side that eventually went in his head. And I started by figuring out, these are the serial wombats. I can't talk good enough about these, man. I absolutely love them. They're just insanely stupid little circuits, but they're so cool. They go on your I2C bus, and they each have their own address for the I2C bus, and they give you a serial port. So that's really cool. But they were all prototyped out here, and since I've removed them and soldered them to the board up in here, I've been using this bus to add and interface other I2C devices since then. Eventually this will all go away and get cleaned up, and I'll prototype something else over there. But that's our Bluetooth radio. That's an HC06, I believe. And that's what allows us to hook our Bluetooth app to it to help with his speech recognition. Speech recognition is ran by, oh, don't do that, come on. This app that I have installed on an Android phone. It says Google because it uses the phone's onboard Google stuff, but this phone itself is not connected to the internet, and it does not have the capability of connecting to the internet. Its cellular radio has been removed, as well as the SIM card, so its only wireless capabilities are via Wi-Fi or Bluetooth. But you can hit the button and talk to this, and it'll determine what you're talking, and then it sends that as a data string over Bluetooth to this, where it receives it. And this is eventually going to get reinstalled back in his head. I just haven't figured out how I'm going to mount it yet. Once it receives that string, it determines what to do with it, and we'll go over a lot more of that kind of stuff in the software overview that I have yet to record. Both arms are 6 degrees of freedom, I believe. and they have a full range of movement. I wanted to make sure he could do a lot of the motions. I wanted them to do things like dance. So he can dance. And he's got enough range of movement with his body that he can bring his arms out and around. He can touch his hands together. He can reach his back and put his hands behind his head. And this was important too, because when I start playing with vision, which I did recently, I knew one of the early things I wanted to do was I wanted him to be able to find like colored balls and pick them up and then drop them into a basket on his back. There's another robot, I want to say Shinzo Robotics. I can't remember the guy's name. He was a lot of inspiration for some stuff that I've built. He's got a robot that can do that with, I want to say like gym socks or something. And I always thought that that was really cool. So that kind of seems like a milestone for me to accomplish with his development. The screen on the chest is a 4x20. It's blue. We've gone over that. This is an I2C backpack. Yes, I should have just bought a new screen that was already I2C, but I didn't, because installed on his back here, we've got a whole bunch of stuff that we haven't talked about yet. This controls the brightness for the screen on his chest, and I always thought that was kind of cool, and once I installed it, I never wanted to uninstall it, so I just haven't. This is a program switch. This is connected to the ESP32, and it sets one of two flags depending on which position it's in. One of three flags. It's a 3 position, so you've got position 1, position 2, and position 3. Now, this is an on, off, on switch, and some of you may wonder, how do you get 3 positions out of a switch like this? Well, you can read the off position as a condition. So that gives you condition 1, which is pin 1 is on, condition 2, which is all of them off, and then condition 3, pin 2 is hot, right? So that's what I use. And depending on what this is set to, when he boots, he does different stuff. I can put him in a diagnostic mode this way. I can run him in manual mode, or I can run him in automatic mode. And automatic is where he spends most of his time. Manual mode allows me to send commands via serial string to him, but I'm phasing that out, and it's not going to work anymore pretty soon, and this will get replaced with a different function. These are power MOSFETs. They're controllable with PWM. You can send a signal to them, and they'll turn on and turn off, whether the signal's there or not. And I use these to control power to different parts of the robot. One of these runs the power for the necks and the waist servos, and then the other 2 each independently control power for an arm. That's to save power so that the arms aren't powered unless we need them. Lots of these Tamiya connectors for various things to get power. I like modular designs, so you can easily unplug. Maybe not with one hand. I'm gonna make a liar out of myself. Haha! You can easily unplug the arms to take them off and test them. And that was another thing I did when I first started building this. My daughter actually helped me build his chest and his arms. And one of the things we did was make it pick up, we just drove it with servo controllers, like a can of Pepsi. And it can lift a full can of soda. And I was pretty happy with that. I don't think he's ever gonna really have to lift anything heavier than that. You can see here on the back side of that connector, I haven't finished this. This pins for the PWM signals don't connect on this side. And that's why here a little later, when I make him move, this arm won't work. On this side, however, you can see all of those connections are there. And those just piggyback these, that's probably not the right term to use, piggyback, but I cut these servo extender cables, and I plugged them in on the board down here where the servo pins are, and ran them up to the connector and soldered them and heat shrinked them and did them all nice. This is something we went over a little while ago before I had a break and couldn't do much. This is 4 USB car adapters from Dollar Tree. And I waited, and I waited, and I waited, and I waited, and I waited so long to get my adjustable linear regulators and my pack of 7805 linear regulators, and they just never came. And I got so tired that I said, screw it. And I went, and these are all 1.5 to 2 amp range. They say one thing, but you never really trust them. You know, you just kind of figure they're in the ballpark. but by putting them together in parallel, I can get a lot more amperage out of this as a cluster, and it does work. It comes off the main latch, which I've explained in another video, and you'll see another Dollar Tree USB adapter here. That's to provide the 5 volts for that's an isolated 5 volts for the latch to work before the robot's powered on. So that comes through this MOSFET, which this one's the same as those. Power comes into the machine on these 3 sets of cables, and then it powers these up. This is currently unplugged. This goes to one of the battery packs. This feeds the power to the power couplers. And then I took 1 wire and I split it and heat shrinked it to make it 4 wires so that I could get amperage from all of them. And it works. You'll see here shortly, it'll run the arm, it'll run the neck servos. The voltage sags too much on this though. I get between 4.9 and 5.1 volts when it runs, and that's just not enough for this servo in here on the waist. It needs 7.5 volts, 6.2 I think on the minimum for it to function properly. He's got a full infrared package. One of the things we can do with him is play laser tag, and you'll see he's got an infrared receiver on the back. He's got an infrared receiver on each arm. I haven't cut the windows out for the receivers yet on this. I know some of you are noticing. I know. He's got one on his chest. So from the 4 of those, he can determine whether he was shot from the front, the back, the left, or the right, and that allows him to turn and face his attacker. We have a cheap laser gun set that we use. It's from Walmart to play laser tag, and I decoded all the infrared frequencies from that gun set and installed that into his code. We'll go over that as well in the coding video so that he could play laser tag with us. And this is his little machine gun infrared blaster. I don't know if we can see the LED in there or not. It's just a ballpoint pen. I cut it up, painted it black with nail polish, and installed a infrared LED in it. And then that's a strain relief. That's why it's all twisted and quiggly. And it runs around the arm and it goes up and it connects. Goes through that DS9 connector. His body, he isn't actually a kit. He's made of bits of kit. And aside from the tracked base, everything else was kind of built with random parts ordered. This is the same metal that these are made out of. And the hands I ordered as hands. I admit that one. I gotta adjust my terminology, whatever, for that. But the rest of him is they're either this bracket, which is this bent U bracket, or it's these servo brackets. So I just bought a couple of bags of those and started bolting stuff together until I had the shape and the design that I needed. His chest is made, these are a bit longer, they're like a U bracket, and they run 3 servo horns wide. And there's another one up here in his head that his head stuff's all mounted to. This is his GPS module. It gets really good reception up here, even with the touch sensor behind it. This switch controls whether I'm programming the ESP cam, nothing, or the ESP32 when I plug them into the computer. This is actually the camera. I had to get a longer corded camera, and this won't be working because I tore the camera cable, so we won't be able to demonstrate that today. But he does have facial tracking. One of the admins turned me on to another camera system for visual recognition that I may be using as well. One of the goals of this project was a multi-processor system. So anything and everything that I can offload on a chip, I'm doing it. Both arms are eventually going to become I2C devices. I'm going to put an Arduino Nano in each arm, and those are going to run the entire sensor packages for the arms so that he knows how hard he's squeezing something and what he's picking up with additional information from his hands. We also want to get some trigonometry going with the servo positions so that we can determine in 3D space exactly where his hand is at based on the positions of the servos and what's being sent to them. This is a battery eliminator. This is one of the ones that showed up. I'm still waiting for more. It does 5 volts at 5 amps, and it does 5 to 30 volts input. These are really awesome for when you run a whole bunch of 5 volt shit, because the amperage requirement adds up on them. The ESP cam draws a couple of amps all on its own, and then I've got 1, 2, 3 displays. Those eat up